Okay, so now we're going to do the Q&A session. And of course, the questions are for all the speakers. And we're going to start with one for Erik, which is, says here, what problem was the current voting system trying to solve? Was it a good idea at the time?
Well,
Erik, are you there?
the current method in the US is primarily plurality rule, as I mentioned. So everybody votes for one candidate. I think the only principle that does a good job on is making vote counting easy. If you're only voting for one candidate, tabulating votes is not a problem. And this probably was a concern in the 18th century when we adopted this voting method. Now it's of course no longer a major concern at all. We have high-speed computers and we can use essentially any voting method we want.
Okay, thank you, Erik. A question for Rajiv. How exactly do bots improve the predictive qualities of markets?
So the bot is just representing the model. So one can ask, how is it that the model becoming a participant in the market improves the predictive quality of the market? Or alternatively, you could ask, how does the market improve the predictive quality of the model? So those are sort of equivalent questions in a sense. And that's a research question that we want to actually test empirically. But my intuition would be that they improve each other. The markets improve the models improve the markets. The models allow you to have liquidity in the markets. Even if traders are not very certain, the model will give you some anchoring. It'll give you some prices at which you can buy and sell. And it's a bulwark against the kind of manipulation that I talked about. So that's one way in which the model could improve the market. Market improves the model because it can take into account very quickly qualitative information that the model just can't do until that information just gets translated into the machine readable form that the model is then going to operate in. So they work to improve each other. At least that's the hypothesis, but it's a testable hypothesis that we want to test.
Thank you. A question for Andrea. So it says here, does the concept of efficiency apply to dark markets in the same way it does to conventional markets? And what is being optimized in dark markets, if anything?
Yeah, that's a very good question. Can you see me? Yeah, I don't see myself. Okay, okay, cool, thank you. And we don't have information about prices, or better, we didn't have information about prices of goods and listings at the level of the analysis I've presented now. We have started looking at this aspect. Of course, getting the data is not super easy, but we are improving a lot. What we did is we checked the transactions, but we don't know what a transaction corresponds to at this level. I use the word efficiency because what it seems they are very capable at doing is this coordinating migration from the shutdown market to the same other market, which somehow guarantees that the system as a whole persists even after closures or due to scams or police intervention. So this is how I use the word efficiency to this point. Your question is very interesting. As far as I know, nobody has yet looked at pricing dynamics there.
Okay, thank you. Here's an out-of-the-box question for Rajiv and Erik. It requires maybe some creative thinking. It says here, the build-up to the election is in a way a test of the candidates. Could we combine Erik's voting algorithms with prediction markets or something similar, so that voting's not just a one-time thing, but kind of a dynamic evaluation? So moving away from this kind of point model of voting to something that's dynamic, evaluated over a period of time. Erik or Rajiv, you want to try addressing that?
Erik,
Sure. Would you prefer to say something, Rajiv? I can start. Maybe
I'll follow you, Erik. You go ahead.
Okay. Of course, one of the difficulties in making predictions in general elections based on based on events that occur before the general election, is that we don't have as good information about voters' preferences as we might like to have. That's one additional advantage of the sort of ranking systems that I was advocating. We will have more information about voters, even voters who didn't vote for any of the candidates, who didn't prefer any of the candidates who end up in the general election, will have the opportunity of expressing their preferences in primaries about those candidates. And so if our prediction models are based in part on what goes on in primaries, we will know more about voters' preferences.
Mm-hmm. No. Rajiv, you have anything to add, or should we move along?
Just very briefly, I don't know if this is what the question I had in mind, but you know, when somebody drops out, for example, people may want to reevaluate, or when new information comes up, and this happened a lot with absentee voting and early voting, right? Because people may have voted when a whole bunch of people dropped out of the Democratic primary, they then, you know, didn't have the opportunity to change their votes. But I think Erik's systems takes care of that. Actually, it'll just act as if those people had not been preferred and move on to the next person on the list. So I don't know if this is what the person had in mind, but that's what it made me think of.
Okay. Another question for Andrea. What's the difference with classical segregated markets, meaning markets on a type of specific product? Does the ecosystem follow the same migration dynamics, or is it specific to the dark market?
Yeah, that's a very good question. So there are a few markets that are more specialized than others in the dark web. Like, for example, there's one that used to specialize on stolen identity and stolen credit card information. Most of them are generalist markets. And at the level of our analysis, the best predictor to understand where they will move is the volume of the market itself. So it seems to be sort of generalist dark web versions of services as eBay, if you want, of course, with a huge difference due to regulations and goods sold. So the answer is we haven't looked at this. It seems that the migration is from a generalistic market to another.
Okay, thank you, Andrea. Another question for Erik. It's sort of a technical question about majority rule algorithm. So if a majority rule were adopted, then what happens when a Condorcet cycle such that A is greater than B, B is greater than C, and C is greater than A in transitivity actually occurs? Flip a coin or revert to Borda count?
I didn't have a chance to talk about that, but it's naturally something that voting theorists have thought about. You could make a good case for either the Borda count or for a randomized procedure, depending on, again, what it is you want out of a voting rule. There's a sense in which majority rule and Borda count are really the two best of the many imperfect voting systems we have. And so using Borda as a tiebreaker is a good idea. But there are also some circumstances where if there are three candidates who are cycling, you might want to determine the winner at random. I should point out that in reality, the evidence suggests that kind of cycle almost never occurs. We have a lot of evidence on this from Australia. Australia has been using ranked choice voting now for over 100 years. So we have thousands of elections for which we have data. I had a student recently who looked at elections since 1993, 1,500 elections in the lower house of parliament in Australia. There was not a single example of a voting cycle in that data. So it's a theoretical possibility, but it's not practically very important.
Okay, thank you. So maybe one final question for all three of you. Here it is, let me get it. It seems like all of you could say something about this. So where is it? Oh yes. So these algorithms that are being discussed are, to some extent, I mean, they're about consensus in different forms, and they separate or treat only the voting process and keep it separate from this evidence accumulation process the voters use to make a decision. Could we design an algorithm that also takes that evidence accumulation process into account? Is there any way that we could think about that, or directions to move in?
Well, interestingly, Condorcet, who was promoting majority rule for the purpose of aggregating disparate tastes or disparate preferences, also was concerned about aggregating information. And it can be shown, and Condorcet was the first to show this in a limited way, that majority rule has very good information aggregation properties as well as preference aggregation properties.
Interesting. Rajiv or Andrea?
I think if the spirit of the question is that some voters are going to be basing their decisions on more thorough parsing of the evidence or greater information than others, then I think you're going to end up, anything that accommodates that is going to end up violating anonymity then. And so that could be a problem, you know, which is continuously discussed in democracies, is, you know, low information versus high information voters. But ultimately, you may want a system that preserves anonymity, even at the cost of not aggregating information all that well.
Mm-hmm. Andrea?
In the cryptocurrency space, there are these decentralized autonomous organizations where masternode, I mean, the voting ends at a given time, but you have the whole history visible, and basically you can continually change your opinion, which somehow incorporates this to an extent. Mm-hmm. And it's all very experimental though, and understudied so far. So, but it's very interesting.
Okay, thank you guys. That was fantastic. And I think I'll turn it over.
Could I just follow up very briefly on what Rajiv said on different voters having different qualities of information? It's sometimes argued in this country that we should have mandatory voting, compulsory voting, so that everyone gets out and votes. But if what you're concerned with is information aggregation, then actually compulsory voting works in the opposite direction, because you're forcing people who actually haven't thought about the problem very much to go out and vote, and that just adds noise to the system. So an important argument against mandatory voting.
Interesting. Noise, of course, can have complicated role in things. Okay, guys, thank you so much. That was fantastic. I'll turn it over to Chris now to wrap things up.
Thank you very much. Thank you, Jesse.